Thank you so much for the invitation. I feel very honored to be here with all of you. And it's hard to follow something that's about environmental justice when I'm about to talk about Lake Tahoe, where we have some of the cleanest and purest water. So if you're looking for clean water, live at the top of the watershed. Whoops. Lake Tahoe is a beautiful, large lake. Have you been there? Raise your hand if you've been there. Okay, many people have been there. It's near here. Surrounded by a ring of mountains, and it forms a small bowl-like basin, so it provides this really beautiful, contained environment for investigation. We host place-based education programming to promote learning that is rooted in our local place. We explore student connections with our local environment, from local geology, water quality, our aquatic food web, and climate change. And our small science center, our research, we've conducted continuous lake monitoring since 1968. And some of the earlier measurements were even before that. But we have this great long-term record of change for one of the world's most beautiful lakes. And it is an invaluable tool for us to understand the ecosystem function and change over time. Our science center is the extension of that research. So we host various education programs from our regular group visits, field trips, science lectures, special events for thousands of visitors every year. But our facility is incredibly small. So you're not thinking exploratorium, you're thinking this room is the size of it. And the exhibits include our virtual research vessel, which is shown, which you saw in the previous picture, but is shown here as the exhibit, modeled after our actual research vessel, our virtual laboratory, aquariums, some posters and photo walls, and then the exhibit that everyone probably, or our most famous exhibit, and maybe you've seen it before, our augmented reality sandbox. So I'm again curious, raise your hand if you've seen this in operation somewhere. So about a third of you. So the augmented reality sandbox was a result of the National Science Foundation funded project to support informal learning in museums and science centers to discuss information about freshwater lakes and watershed science. The software was developed at UC Davis. The exhibit structure that you see was actually designed at the Exploratorium, but the first 4 exhibits, the first 4 instances of this from about 6 years ago were at the UC Davis campus, the Tahoe site, the Echo Lake Aquarium and Science Center in Burlington, Vermont, and then also the Lawrence Hall of Science. So that was the small, medium, and large version of that. And so sand is augmented in real time with an elevation color map, topographic contour lines, and simulated water. And I have a cute video of this. Let's see if this works for me. Yes. Whew. Okay. So a 3D Connect camera detects the height of the physical sand. It's just white sand. A short throw projector projects the color map onto the plain white sand. The camera detects your hand. And if you're fast enough, your hand doesn't show up in the topography, but you can see the different colors. And then if you put your hand out like as such in the right elevation of where clouds that form precipitation, the water will flow down, and it flows down using a real water flow equation. So it flows downhill and it gathers in the low-lying areas. And when kids and families approach this, depending on the lighting of the day or the room, it is incredibly instantly engaging. People start playing in it. It has this zen feeling where you want to kind of move the sand around because you see an immediate response with what you've done with your hands. Whenever I see this version of the video, I remember that we used to have blue was what you would dig down to, but then we did some of our formative evaluation and people thought blue was water, but water is actually that other blue. And so that was an error that we made initially, was now you dig down, it gets down into from green to brown. But here you can see the kids very excited, and that is a different type of sand, so you can use the kinetic sand or the regular sand. But this is a really engaging, fun exhibit. The dwell times are long. In our field trips, we have to sometimes like drag the kids away. We're moving on. And so we're really proud of this. and I'm just going to skip ahead. So with this exhibit, we teach geographic, geologic, and hydrologic concepts, such as what is a watershed? How does water flow? Where are lakes or reservoirs formed? Flooding, what happens when flooding happens? Dams breaking or levees breaking? How to read a topographic map and the meaning of contour intervals. And because the software was funded, the UC Davis written software was funded by a National Science Foundation grant. It is open source. It is available on arsandbox.ucdavis.edu, but we now have over 720 exhibits that we know about on every continent except Antarctica, unless anyone knows about one on Antarctica. Because it's no longer a funded project, it's hard to keep track of, but there are also new, sorry, I'm gonna skip ahead, new versions of the software that are available, but no real way to get that out to everyone. But new versions where you can import a specific watershed and then, the San Francisco Bay Area, and then it tells you by color where to add sand to so that you can actually build that watershed. We also have put in a plastic 3D model of our own watershed that kids can also play in, and you can see what happens if the lake level's very high. How does that change the shape and the beaches and all of that? I also wanted to tell you about other visualizations that were funded under this lake visualization project. And these interactive visualizations require a joystick to move or fly through the data, and that takes a lot of practice to operate. And one thing we learned from our formative evaluations were that other kids don't like to watch other kids learn how to use the interactive tool. And this is a look inside our small 3D theater. It seats about 20 to 25 people. So again, thinking about scale, we are a very small science center, almost more like a visitor center than a science center. There's the joystick. And I have this, this is a video clip of our LiDAR data set with the satellite image overlaid on that. And so we can fly through this data around our watershed. Of course, everyone wants to go to their own house. That's the first place you want to go. And it represents a really beautiful representation of the landscape, but the data size is really unwieldy, and flying around, you can sometimes get lost. And so our volunteer docents, we can't really ask them to do that. It doesn't work well, and you don't get consistent representation of the content that you're trying to get across. So we developed some passive visualizations. We canned the information into 3D movies, and these movies incorporate similar content, but it's much easier. You just press play, and based on our evaluations, we know that consistent information is being presented in a way that works. Kids put on their 3D glasses, they come into the small visualization center, and they love the glasses, and then we can play a movie. So I've just actually for the first time learned how to edit videos. And so here's the edited clip from our short film that's a part of most of our visitor tours. So you're going to take a flight through and around Lake Tahoe, and you're viewing the landscape as an earth scientist, and the three-dimensional image is made from measurements of the land elevation, the lake basin depth, you're seeing that, and satellite imagery. You can see the three major faults that formed Lake Tahoe, and we talk about the different things that have happened, the glaciation, the erosion, and then a underwater landslide that caused a large tsunami about 50,000 years ago. I always make the joke that if anyone has lakefront property that they're afraid of living in, I will gladly live there. We have this seismologist developed computer model of what that would have looked like, that giant tsunami. And so we can show evidence of extreme events, earthquakes, glaciation, droughts, underwater landslide, all of that, and that the shape of the land is a record of all of these events. So we see, and Lake Tahoe has a pretty iconic shape. There are all of the Keep Tahoe Blue stickers that have the shape of the lake, and we are highlighting some of the things that maybe people haven't seen, like what it looks like under the land or around the watershed. So that is the video. We also have some real-time data that we share, And so the next visualization I'll talk about is the Lake Tahoe In-Depth Touchscreen exhibit. And I want to thank Eric and Eric, Eric formerly from Stamen and Eric from Stamen, that helped develop this. And also Tisha, who was our exhibit developer as we worked on this. For visitors that come to Lake Tahoe, this exhibit allows them to explore this place. So now let's see if I can skip out. So I'll just show you a canned screen. So basically what we have is I can go to the different places and they have the seasonal imagery that shows you each place by season. Then we also have, this is a sample screenshot of our annual cycle of air temperature, and it shows the actual air temperature around the lake and on the research buoys that we have in collaboration with NASA. And so you can see the historical data, the past week, today, next week. You can see images from around seasons. You can see activities around the lake, citizen science data, the river and stream conditions, and the lake conditions. And so this is a lake conditions. So this is looking at water temperature. And something interesting that's happening here is the water temperature is going from 57 degrees to 42 degrees in one day from an upwelling event following a major wind storm, and so, or a storm that had a lot of wind. And so we see that happening, and that is a pretty steep drop in temperature, and that is interesting. And some of the other things that are available are things like wave height, so people can decide if today is a good day for kayaking or paddleboarding, or perhaps not. And then, so I have these canned ones just in case the online thing didn't work for me. The last thing I want to talk about is our Citizen Science mobile app. So this is Citizen Science Tahoe. So we're asking people to report on what they see, the algae, the water quality, invasive species, beach litter or litter in the water, or even overflowing trash receptacles to try to protect our bears, and then the stormwater infrastructure. So people are making observations in real time at the place that they're at around Lake Tahoe or in the region to make them more aware of the issues that we face, and also help them to become better stewards of the land. And so locals and visitors alike can be involved in the Lake Tahoe science and protection efforts. And I am coming soon. We're working on an augmented reality exhibit. Hopefully, we've submitted a couple of proposals. We've had some local funding to get us started, and we want to include a virtual underwater Lake Tahoe, some information about changing forests and the risk of wildfire, and then other things in understanding change in mountain environments, the climate change, how we're affected. So I've shown you our augmented reality sandbox, our 3D visualizations, both interactive and canned, our real-time data visualization, which I kind of didn't get to show you, and our Citizen Science Tahoe data collection tool. And so please come check us out. And I just wanted to end this. I know you're just a couple presentations away from the end. So come visit us in Lake Tahoe. We're located on the north shore of Lake Tahoe in Incline Village. And now for your moment of Zen. There it is.